As you all know, we're in the middle of the most important revolution in the history of mankind, the information age. The history of computers is the story of people, the technology we create, and how it has forever changed how we live. As Nicholas Negroponte of MIT was quoted saying, "Computing is not about computing anymore. It's about living." We see ourselves as the most important institution helping the world understand the relationship between people and technology. We look at the history, the unprecedented impact of this revolution, and while we're also discussing the future possibilities for these technologies. Tonight's program is a great example of that phenomenon. Okay, tonight is the second of a two-part series on the impact and implications of artificial intelligence. We've been putting these together with the Partnership on AI. So let me get out of the way and introduce our speakers. Jan LeCun has been Director of AI Research at Facebook since December of 2013. Before Facebook, he was the founding director of the NYU Center for Data Research. Greg Corrado is a principal scientist at Google Research and the co-founder of the Google Brain team. Prior to that, he worked at IBM Research on neuromorphic silicon devices, large-scale neural simulations. Eric Horowitz is our third panelist. Eric is a technical fellow and director of Microsoft Research Labs. He's been elected a fellow of the Association for the Advancement of Artificial Intelligence, the National Academy of Engineering, the American Academy of Arts and Sciences. He served as president of the AAAI and is a member of several advisory committees, including the National Institutes of Health. Our moderator tonight is none other than John Markoff, a Pulitzer Prize-winning journalist and author. He joined us here at the museum formally in January of 2017 as one of our historians. As you probably know, prior to joining the museum, he was the business and technology reporter of the New York Times for nearly 30 years. Fabulous group of people to talk about artificial intelligence tonight. Please join me in welcoming Jan, John, Greg, Eric.
Thank you. So if you go to a lot of these panels, they usually take the form these days, artificial intelligence, threat or menace. And I think that this is going to be really fun because we're going to do something different. We're going to focus tonight on the deployment of AI technologies for the benefit of society. So this is the positive side. And of course, the first question is whose benefit? But we'll get to that in a while. And sadly, we're in this situation where last week, world leaders like Vladimir Putin, Putin didn't say whether AIs will eat us, he asked when they will eat us. Vladimir has probably been watching too many Terminator, too many versions of Terminator, but issues of cannibalism are probably the last thing that we are going to think about when we think about AI. And, what's going to happen when Donald Trump finally wraps his mind around AI? But with that in mind, I want to start, we have three really important contributors to the development of this technology in the last decade to 2 decades to 3 decades? 3 decades, 4 decades, actually. So I want to start by asking them about the rate of change, because it will be very different if AI is disruptive for good or ill over a decade span versus whether it's disruptive over a century. And so I want to start by asking each of you to give your sense of the rate of progress and how quickly this field is advancing. It feels like it's extremely compressed and that all the stuff that is having an impact on society is happening over the course of just 2 or 3 years. You guys have been around for a long time. What is the rate of progress? Do you have a...
My sense is that we're truly now, maybe the last 7 years to now going forward at I would call an inflection point for these technologies. And I think it's largely due to a confluence of several related technologies and some happy surprises. The internet and the crash in the price of storing data gave us a wealth of data in so many areas, and that data has people don't remember that a few years ago, it cost a lot of money to go out and buy a 40 megabyte hard drive, even during my grad school, 4 decades ago, I guess it was. Just teasing about the 4 decades. But maybe I'm not teasing. I got to add this up. And at the same time, we've had incredible computational resources zooming up. And those two things that come together provided, I'd say, the fuel for great algorithms work and applications. And then we have this competitive terrain among big companies, and academics, to sort of who can do better and who could ship more products and do more services. And that also adds fuel to the incredible inflection point fire.
So, so is it exponential? Let's not talk about silicon for a second, but let's talk about your field. Is it on the same kind of exponential pace that the underlying silicon is? Or, your field, I have to be direct, has overpromised and underdelivered for a very long time, going all the way back to McCarthy. So is it different now, is I guess the way I want to ask this.
So there's been a number of waves, of course, different techniques appear and people are excited about it and promise the world. And then, when it turns out to be more difficult than expected to deliver, then, enthusiasm dies a little bit. Or sometimes the wave actually produces real contributions that are then renamed and not called AI anymore. So if you think about the first wave of machine learning in the 50s, the perceptron and things like this, the first machine capable of learning. It was shown in the late 60s that those models were very limited, and people kept doing the same thing, except they didn't call it AI or machine learning anymore. They called it, adaptive echo cancellation or something like this. It's basically what goes into your, the horrible noise that goes in that your modem used to make when you turn it on. That's actually a perception algorithm running there, and so the cell tower that figures out how to beam, stuff to your cell phone. It uses a very similar algorithm. And your spam filter also does. So there is a lot of heritage in this thing, but it's just not called AI anymore. It used to be also that the algorithm that's used by Google Map or whatever to plan your trip on your on your map. That used to be called AI. It's not AI anymore.
It still is, actually.
It's still in the AI textbooks. Yes, that's right. So yeah, there are waves. So I think it's very interesting to see the acceleration of interest and sort of new ideas and new applications that came out in the last 7 years. But I think it was kind of long in the making in the sense that when I started working on this in the late 80s, I thought the progress would be considerably more continuous and not, basically stagnant for 20 years and then just, a really fast takeoff. So I think what happened was exactly what Eric mentioned, that another set of technologies had to line up before that takeoff could occur.
Okay, so Greg, how much then, if that's true, how much of what so before we came out, Jan was talking about how ideas that were around 10, 20 years ago didn't work then, they're working now. So how much of it is a free ride that you're getting now because of the increase that you get from silicon, and how much of it is fundamental ideas in artificial intelligence?
Yeah, so I think that it's really that these technologies, in terms of the availability of computation, is unlocking a storehouse of ideas that have built up in the academic community over decades. And we now have the technical capabilities to make these things practical and accessible and really useful. And so I see it as we make these breakthroughs, it's kind of a punctuated equilibrium kind of situation where, yes, there is rapid transition as we're able to exercise some of these ideas that we've been brewing for a while. But then I think that there will be other new breakthroughs that then trigger new new changes, but I don't think that we should imagine that the current rate of change is a constant, right? I actually think that we will go through variability and things speeding up, things slowing down, things speeding up, things slowing down.
Okay. So if I asked you guys to put yourself on a spectrum, where on one end of the spectrum was Ray Kurzweil, who's a colleague of yours, who was, so he's very systematic about charting the rate of progress. And I think at the moment, artificial general intelligence, that is a machine that can do everything a human can do, he puts that at about 2027. And it's the singularity or this intelligence explosion, he puts at 2045. Let's put Ray on one end of the spectrum. And on the other end of the spectrum, let's put Robert Gordon, the economist who makes the argument that computer productivity happened. There was a bump and it's over, I'm sorry. So place yourself on that spectrum.
Let me make a comment. We started out talking about inflection points and excitement and the confluence of the right things and fuel. But from the point of view of the dream of the founders of the field of AI in the 1950s, we've had some bumps recently in terms of what I would call building very competent, narrow wedges of intelligence. But if you told Marvin Minsky and Herb Simon back in 1962, here we are in 2017, and we're talking about being at an inflection point, they would fold their arms and say, well, you can't do what a toddler can do yet. You don't have the common sense reasoning. You don't have learning in the wild, the lifelong learning. There's so much we don't know, and it's unclear right now to many of us. I think this is a question. I'm glad this is being archived because we'll look back from 2027 and beyond and see where we were and where we were going. But it could just turn out that this bump in the ability to do incredible pattern recognition was just that, a bump leading to some disappointment in not going further towards this dream of understanding some of what I would call the deeper mysteries and magic of human intellect.
Yeah. And yes, on that note, a lot of the research that goes on in our labs has to do with that next step. So we know that the techniques that we have at the moment are limited in their capabilities. And we can probably coerce them to do things like driving cars and recognizing tumors on X-rays. But beyond that, we can only train them to do tasks for which we can collect lots of data that has been annotated by humans. But we haven't unlocked the mystery of how animals and human babies learn so efficiently and so quickly. So a lot of our research at Facebook and the similar projects at Google and Microsoft have to do with what we could call predictive learning, unsupervised learning, there's things like this, various forms of reinforcement learning that, perhaps would lead to the next progress. But we haven't found a solution to this. Until we find it, we're not going to have machines with common sense. We're not going to have, chatbots that actually understand what we tell them at a deep level.
So closer in, then there is a community in Silicon Valley who really has deep faith in the power of machine learning algorithms. And for example, there is a school of people who believe we'll be able to get to level 5 self-driving with just neural net or related machine learning technology. Do you think that that's possible?
Yeah, it's possible. Yeah.
So that's possible, but that, to me, that doesn't mean that we're anywhere near artificial general intelligence. Because, so I believe that there are many very useful, very productive, and very fun things that we can do with these kinds of narrow and very deep intelligences. But to me, having a breakthrough in focused intelligence doesn't portend that we're about to make a breakthrough for general intelligence, that this vertical innovation means that we're close to a horizontal one.
I'll make the point that many people, I think, feel like me, colleagues in the field of AI, we're in it because we have this incredibly surprising existence proof that it's possible for computation to generate intelligences, and that's human beings and closely related animals, vertebrates. It's just amazing. We know it's out there. It's tantalizing. It's close. These are biological machines, yet somehow we haven't gotten to that next level of thinking. I don't use the phrase artificial general intelligence as a thing, But I look at it as an incline path towards something like that, being more general, having more abilities to learn in the wild, understanding common sense, integrating multiple competencies in a fluid and magical way. We don't know how to do that yet.
But so we're 50 years in, well, we're more than 50 years, we're 60 years in. None of you would quarrel with Dreyfus's tweaking of Papert and Minsky, like was it in '69, where he said that their assertions that they were making steady progress toward an AI was a little bit like a man standing at the top of a tree saying he was making steady progress to the moon. Would you all sort of, it's been 50 years, that's still?
It's a healthy comment.
Okay. Well, so let me jump for a second to your organization. So one of the interesting things is this is an industry where the technical practitioners have really sort of said that this stuff is going to have an impact, and we have responsibilities, I guess, to more than your shareholders when it comes right down to it. I want to ask you to talk a little bit about where you are with the partnership for AI now, and in particular in terms of where you're going to cooperate and where you're going to compete. And I mean, it's interesting that OpenAI, which is sort of what I think of as one approach within the AI research community, is actually a member of your group, but then you are corporations that have basically, you do publish, I think all of your companies publish a lot, but you also have a proprietary strategy. So how do you mix this proprietary and open stance that you're trying to articulate?
I mean, it's interesting. OpenAI is not just a member, but Greg Amadei from OpenAI is on our board, helping to direct what we're doing. I like to, with optimism and hope, reflect that what we're doing is pre-competitive, working on things that all the companies care about, as well as nonprofits and civil liberties organizations together. Now, it's true that the partnership was created by the scientists, the AI scientists at all the companies. You might say they dragged their companies along, but I think it was actually more of a resonance with the leadership of the companies that this was a good thing, that we would all be better off if we cooperated on these really hard questions, and several of them we're actually addressing directly as pillars of our organization.
Yeah, there are questions, a lot of those questions that go beyond each of our companies. Then there are ethical questions and things like this that are a little difficult to answer by yourself, probably have, deserve some discussion in the open, because these are discussions that the public should contribute to as well. So one of the purposes of the partnership is to provide a forum for those kind of discussions. Also, perhaps produce guidelines for the proper use and deployment of AI technology, particularly to smaller companies and organizations that don't have the resources to really think about those things in the long run.
Could you ever see the organization sharing code?
Yeah, oh, absolutely. Oh, yes. So, I mean, I actually think that the open sourcing of code is, this is something that all of our companies participate in and is part of the natural ecosystem now, that there are really important parts of what we build that are open sourced and should be open sourced. And then there are other parts of what we build that are proprietary to the products, and these are, the parts on which, we will compete and try to make a difference to the user that makes them like your product better. But there's a huge swath of things that go into scientific exchange, scientific reproducibility, security, and the ability to build standard engineering systems that demand open source code sharing. And all of our companies have extensive open source projects.
I can give a quick example, just a fresh one, in fact. Several of our companies have independent efforts going on. I know largely about the one at Microsoft, on thinking through several different kinds of questions about how AI will influence people in society, including ethical questions, questions about fairness, questions about how humans and machines will interact, how they'll work together and collaborate someday. On the fairness question, learning understanding whether or not a system built from lots of data it treats everybody fairly is an interesting and deep question. And at Microsoft, as an example, we've thought through code, definitions of fairness, actual code that you use to test with a workload. And at the tip of our tongues and in our conversations is, of course, when we converge on this, we're sharing this out with the partnership. We're going to share the code and our thinking, and we hope to learn about other strategies, because that kind of thing should be done as a large community.
Absolutely.
I don't want to. I want to get to AI and social good, but I don't want to give up just yet on this rate of change question. I wanted to ask Greg. I mean, it's this free ride question and where we are, and so I'm of that school that we're at this abeyance, if you will, in Moore's law. I know it's hotly debated, but you can look out in Silicon Valley and you say that the per cost of each transistor has stopped falling over the last 3 years. And so, if you guys were getting a free ride and things that didn't work were working because of Moore's law and related things, if it's flattened out, and first of all, does it look that way inside Google, and what does it mean?
Yeah, so I actually think that there's a lot more to the expansion of usable computation than Moore's law. So even if the price of the individual transistor isn't changing, I feel like the experience in my lab is that the availability and the flexibility of computation continues to increase, and the price of using computation in a flexible and scalable way in clouds and data centers has really, really changed the game. And I think that advances, even if Moore's law were to hypothetically halt. But I think that there is something to be said for, we've realized that some of the ideas that we've been working on for a while are now ready for prime time. And it may very well be that there's a pipeline of these ideas, things that we've worked on that are very close to being unlocked by the greater availability of computation. The next great AI idea might be only 12 years old instead of 25 years old.
Which would be an acceleration.
So on that note, there is a lot of room at the bottom, even if Moore's law stops completely, due to the fact that now we have a model of computation that's slightly different from the previous one, at least for sort of AI-type tasks. And so computer architecture specialists are kind of redesigning the architecture of computers so that they take advantage of the structure of computation that you see in deep neural nets, convolutional nets, et cetera. Yeah. So you'll see over the next year or 2, 3 years perhaps, the fact that you can run fairly complex AI tasks, image recognition, for example, on your smartphone, because there'll be special chips that do this on your smartphone. I actually have a bet with my former department head from Bell Labs from many years ago, Larry Jackal, and we made a bet in 2013 that by 2023, I made the bet that your smartphone will have enough compute power to drive your car. It'd probably be a bad idea to let your car be driven by your smartphone, but basically will have everything that's required for it.
Yeah, I've watched that fairly closely. Let's see, the iPhone 4 had more computing power than a Cray 2 in 1987, which was the world's fastest computer, so that's completely believable. So now I want to get to, you have these 7 pillars in your organization of key principles, and one of them is AI and social good. Did you think about AI for social good? Why did you choose the word and? I mean,
I actually was part of that linguistic discussion, so let me see if I can remember exactly how it went. So the thought was that saying AI for social good implied that if it wasn't, it was otherwise evil and scary, which of course is not true. It's almost like saying electric power for good, as opposed to all the ways it's going to be used someday, which would be terrible, of course, right?
Yeah.
And so the idea of and suggests that machine intelligence has many uses. Let's now focus our attention on amplifying and collaborating around hard societal challenges, and not imply that if it's not for something, it's against something. Yeah. That's the linguistic background on that.
Okay. But then it's still interesting because you have many organizations inside PAI now that are not for-profit organizations, but you three are, you're working for shareholders, and you're in a capitalist economy, and the principles are supposed to be about profitability. you know, what kind of luck are you having putting social good on the agenda of your boards of directors and executives?
Oh, I actually think that that's an amazingly easy sell. So it turns out that most of these technologies that we're working on that drive social good are very much win-wins, right? So for example, like it was a great privilege to be able to work on the new generation of Google's machine translation service, which is something that is of course good for Google because it makes the web generally more accessible. It makes there more information for everyone to potentially read through and utilize. But its primary benefit is actually to us as people to be able to communicate better across language barriers, which I think of as a great example of the way that artificial intelligence benefits society as a whole.
I absolutely, I mean, I agree with you in principle. Have there been any social scientists who have actually looked at what's happening now that people are talking across language barriers? Is there evidence about what's happening?
So like one thing that I can say is that since we improved the machine translation system at Google, we've seen translations between English and Korean go up by 75%, right? And I think you could make a fair argument that at this moment in history, it's good to be able to read each other's language.
Do you have any Facebook stories along those lines?
Yeah, I mean, it's the same, there's doing a lot of work also on translation and also deploying neural nets for translation, and it certainly improved the performance quite a lot. And Facebook's main mission is to connect people, to create community, connect people with each other, and that includes, of course, things like translation. But to your original question, I think those three companies have the luxury of thinking for the very long term, and you cannot, think of the well-being of a company in the long run without thinking of the well-being of all the people that it serves. And so, the point you were making about profits, et cetera, those are short-term objectives. And short-term objectives are, well, short-term. So if, they could be bad in the long run, I think our companies are more interested in the long run, which is why they all have research organizations, by the way, and willing to invest so much in research.
Exactly. I was going to suggest that companies don't exist for profit alone, no matter what shareholders think. Bill Gates didn't go start his company because he saw money. He saw this Altair computer, and he saw a way to empower people and change the world. And Microsoft, under Satya Nadella, recently asked itself the question, which I thought was very interesting: why do we exist? And the mission statement came to mind: to empower people and organizations to achieve more. And that runs through the whole company. It motivates the people working on projects, it helps us recruit, and I would hope it attracts investors.
Yeah. So actually that brings up a dichotomy that I stumbled across a number of years ago. There were these two labs on either side of campus that started at the dawn of interactive computing. One was started by the guy who created the AI field, John McCarthy. He thought he could build a working AI in a decade, in 1962. At the same year, on the other side of campus, Doug Engelbart set out to augment humans. And so you have this classic dichotomy. Two fields grew out of that, the AI field and the computer-human interaction field, which by and large don't talk to each other. But the other thing that I really wondered about, and Greg, you've talked about this, but it's a paradox too, because if you augment a human, you in principle need fewer humans. And I've never figured my way out of that. You disagree?
I completely disagree, right? So,
so do I.
Pencil and paper is an amazing augmentation of human memory and the ability to reason. Like, think about the longest division problem you can do in your head as compared to what you can do with paper and pencil. Paper and pencil is augmenting your ability to carry out mathematics. Yeah. And I view computer systems and AI systems as the natural continuation of that. These are tools that we build to extend our reach and our ability to create and affect the world, and machine learning and machine intelligence is no different.
Okay. I mean, I think also there are kind of several questions behind our motivation to work on AI. So one of them is to empower people to do more, provide better tools, etc. The other one is also a scientific question of unlocking the mystery of intelligence. What are the principles behind intelligence? So it's not just building widgets, but it's also understanding ourselves, and that's a really scientific question that many of us are after. Now that will result perhaps in intelligent systems that are autonomous, but ultimately they are built to enhance or give leverage to humanity.
Now, John, I know you're an expert and passionate about the pillars of John McCarthy way of thinking and Herb Simon and versus Doug Engelbart.
There's a whole book about it, right?
Well, yeah, I knew them both. I adored both of them. I think it was easier to adore Doug Engelbart, but that's another story. It's just more personality thing, but I like them both quite a bit. I think that while those are two different ways of thinking about things and maybe disparate, as you said, there has been a generation of scholars that have come to the fore that look at human augmentation as a really difficult and interesting AI problem.
Yeah, fair enough. So let's dive into the economy. And I first wanted to ask you about transportation. If the cars end up driving themselves, will the world be a better place?
There'll be fewer deaths on the roads. That has to be good.
Okay.
And
how do you, so fewer deaths on the road, how do you respond to Bob Gordon? So Sebastian Thrun has articulated that point of view as well as anybody, and very passionate about it. Bob Gordon, the sort of grouchy Northwest economist, says, look, we've had all these safety systems already put in place, and in fact, there aren't that many people really dying compared to what happened. I think I looked today. The 1930s were really bad in terms of miles per, that was a really bad time. Now we're pretty far down the road. Will it make that big a difference?
Yes.
Yeah.
Okay.
I mean,
Yeah,
look,
definitely.
it's 1.2 million the last I checked of deaths
Worldwide, yeah.
32,000 or so last I checked US. That also discounts, doesn't really track all the lifelong injuries that are disabling, cognition and physically disabling. I've lost 5 family members to surprising, of course there always is a big surprise and a tragedy. You should not have to die going from A to B to get somewhere. And I've always viewed cars as being such low-hanging fruit for advances in making transportation safer. There's no reason not to do this. I think it's been slow to, even forget about automation right now, full automation, level 5 automation, level 3 automation. We could talk about the issues with those. Just smart braking systems that prevent rear-end collisions would go a long way.
Yeah. Okay. So, so now we're talking about how we deploy these technologies. Are you thinking about the idea of individual automation of cars versus the automation of the whole transport system? What if you could apply AI on a sort of meta level? And you've done that, right? Haven't you actually in the Seattle area?
I thought you were going to talk about my meta level of my doctoral research by saying, well, you've done that. Yeah, so yes, we've looked at broader, large-scale areas, actually worldwide now. It was a ClearFlow project, which was to use machine learning to learn to predict road speeds on every single road segment in a greater city area that's now running worldwide in the big maps system. But other examples include some recent work that we've done, which is you have the fastest route, the shortest route, and then you can do some little trades and compute safety on routes from accident data. And now we've generated a methodology that's called risk-sensitive planning that generates safe routes as well.
And I think that this is one of the things that's worth really taking a moment to attend to, which is that the way in which we interact with the systems that we build is actually complicated and sort of a sociological phenomenon, right? And so the availability of traffic data and maps has changed the way that traffic flows, right? And has made for fewer surprises, right? You used to turn on the radio, for the every 10-minute traffic reports, and now navigation software has changed the way that gets executed, and has given the system overall a form of intelligence that it didn't used to have in a surprising way.
Yeah.
So the
Does
the
Facebook-
wide
yeah, go ahead.
the wide availability of cars, in the 50s and 40s created the suburbs, right? I mean, it transformed the way kind of housing was organized and how people went to work, etc. And I think the emergence of self-driving car is not only going to save lives, but it's also going to reorganize cities and the way. I mean, there's going to be other factors like telepresence and virtual reality and stuff like that. But it's going to change the way cities are organized in very, very profound ways. It's probably going to change also our relationship to car as an object of ownership.
Yeah, that's already happened.
So the transformations are really hard to predict because they could be extremely profound.
So I have a bet that I actually made with colleagues, just like you and Larry Jackal. My bet was that by 2030, at least one major city for a certain region would close all traffic to any human-powered vehicles. And you'd have a coordinated, beautiful, highly safe, rapid micro-transit system on the roads, coordinating and being as flexible as cars could be without parking. And once in a while, you get a permit if you want to bring a truck in as a human driver. You drive in, and all the cars would sort of part and there's a primate coming through. You can imagine. So I just think it's going to happen by 2030. Though, and so the point here, John, is back to your comment. I believe that in the end, level 5, as we call it, and so on, might not come through the current course of transition from the current cars, but through a whole ecosystem solution with beaconing and so on, where it's very, very safe, and a lot of the uncertainty is removed, sucked out of the system.
Yeah.
You said 2030?
Yeah.
I'll take the bet. You got a buck?
Archive it.
I say no.
Can I chip in on Eric's side?
Oh, all right. Yes, absolutely. I'll take yours.
So, about the economy, there's another meta question I want to ask if it's come up before you go. We'll come to jobs, but I think more important than jobs, and Yashwaj Bengio just brought this up last week about the issue of concentration of power. What if AI works tremendously well, and the companies that own the AI technology are the beneficiaries, and it creates a lot of profitability, and it leads to the concentration of wealth and to growing inequality. Now, there's some evidence that that may be true already. One is your organization talked about it, and do you guys have feelings about that?
It's a question you have to ask lawmakers, essentially, because they are the ones who essentially create the substrate for inequality to grow or not grow. Inequalities of wealth inequality and income inequality has grown in the US to a considerably larger extent than in Europe, for example, and it's purely fiscal policy. It has nothing to do with us. I mean, we might be on one side or the other of profiting from it or not, but it's really political questions about fiscal policy.
Well, there are. I can't let you off the hook that easily. There are clearly government issues and regulatory issues, but this technology may also be having impact on the economy and changing the shape of the workforce. What, for example, would it mean? A labor economist like David Otter has talked about the danger of the middle dropping out.
Yeah.
What if the AI technologies that have been deployed over the last half-decade have basically destroyed the middle of the workforce? So, I mean, that's a possibility. The economists debate about it, but there is a school of thought that's going on.
But let me, John, separate. You combine two things in your question. I'd like to separate out the big companies owning stuff as being the source of the wealth disparity, and thinking more globally at what happens with automation of new types, where the owners of capital, for example, can produce more cheaply without people. The labor wages go down and so on. And there's signs now, AI, automation, offshoring, for all sorts of reasons. We just did a National Academy report on this that I was part of, where it's clear that the median income right now is separating from the average GDP in the US, for example. You see the separation occurring. So wealth is being concentrated. There's many signs that's going on. People talk about why that might be. and that's a deeper, longer discussion, but I don't think it's going to be because of large companies owning magical secret technology, nor owning lots of data. I think there's going to be a democratization of those tools in general. It raises the question of who's going to use the tools and make lots of money from them.
Yeah.
So I was actually at a meeting with a whole bunch of distinguished economists 2 weeks ago in Toronto. We're discussing the impact of AI on the economy, and they were all describing AI as to my surprise, as what they call a GPT, general purpose technology. And the other examples of this that they were citing as other general purpose technologies were things like the internal combustion engine, electricity,
Interesting.
optics, the invention of the lens, that displaced jobs. Older people couldn't do certain jobs before the glasses were invented, and that completely changed what kind of jobs you could do. So they see AI as possibly having this impact. Now, the next thing they say is that for every technology to disseminate across all corners of the economy, it generally takes about 20 years. Not because, and the main limiting factor is the fact that it takes a long time to train people, essentially. So the fact that you don't have those exponential takeoff of technology sort of going away much faster than people can cope with is the fact that what drags it is the fact that people don't learn things very fast. And so economists talk about technological unemployment, which is the idea by which the set of skills that are required for the economy kind of move, evolve as technology progresses, and then the skills of people kind of trail behind. But in fact, it's that limits the speed of progress of the dissemination of technology in society.
At that conference, was there a consensus among the economists about the technology? Did they, in terms of job destruction, were they pessimistic? What was
So economists are really interested in productivity, and then they were all worried about how. So they're all saying that the productivity generally follows what they call a J curve. So the productivity sometimes goes down because of disruption due to new technologies. And then after 10, 15, 20 years, it starts taking off. So for example, the computer technology started appearing in the 70s, but the increase in productivity started in the 90s and kind of settled on this. But the other thing I think that's important is that it's going to change the value we attribute to things. So the example I use very often is that you can go to a store or go online and you can buy a Blu-ray player for $46. It's a Blu-ray player. It's an incredible piece of technology, very sophisticated. It uses blue lasers, H.264, compression, things that didn't exist 10 years ago, right? $46. It's built by robots mostly. Now, you want a handmade ceramic bowl, 10,000 years old technology, really handmade, it's going to cost you $500. And what's the difference? The difference is human experience, real sort of human contribution. So it's not as if the new technology is destroying the old job. It just gives more value to sort of human contributions. That's going to be the effect, the economic effect of AI.
So speaking of this, so let me just say that I believe that we face great uncertainty as to what's going to happen when we see the rise in distribution and ubiquity of what I would say technologies that incur into the realm of human intellect. I think it's a new kind of thing in terms of many areas of human competency that have not been addressed by mechanism before. I think it's probably a no-brainer that there'll be disruptions on the way. Just looking at how many people in the United States drive trucks for a living, I was just amazed by the percentage when I looked that up. What if that job just goes away over a few months or a couple of years? I just think that what comes to mind, looking back at the various waves of the Industrial Revolution, is there were disruptions, even as the automated loom came to be and the steam engine and the kind of power source in society, in the distribution of wealth. There were, I was surprised to find out that in Britain, in the in the 18th century, loom breaking by anger and by people who were out of jobs and upset and frustrated was given the death penalty. It became such a problem. And so who knows what's going to happen on the way to new kinds of distributions of jobs where we really value human intellect more.
Could you see a world in which you could use AI techniques to plan these transitions? Like so we've got a market economy now. Why not using, people talk about AIs being judges. That's already being seriously discussed. What about the possibility of AI controlling markets to make them more efficient or fairer? Is that?
So I think that it's all of our responsibility to try to, if we believe that we can see that there's a change coming, right, that there is going to be I don't tend to think about it in terms of jobs, but rather in terms of tasks, right? That there are individual human activities, right? Most of them extremely tedious. That if you look at any decade, there were a set of tasks that people were doing, and then they became automatable, and that led to some disruption in the economy, right? I think that it's all of our roles. This is not a role just for engineers, but for society as a whole, to contemplate, well, what do we do in order to ease that transition, in order to make that transition as palatable and beneficial as possible, so that the benefits of the technology are distributed as equitably as possible. I don't think that it has to be any kind of magic or meta issue where AI helps us solve the AI problem. I think this is something that we face every decade with every new set of technologies, and we should always be aware of this, because it's to as Jan said at the beginning, it's to all of our benefit to see that society remains productive and that the middle doesn't fall out, and that's why I think that's why things like the partnership on AI are important, because if we at the technical level can give some additional signal to policymakers and economists about what it might look like, they might be able to devise better solutions for us to make this work.
A good example is the generalization of ATM machines. You would think that the number of bank tellers would have gone down, but it's actually gone up. And the reason is because it made it a lot cheaper for banks to open branches, and they open actually more branches. And it's because, again, human contact is very important to people. So that didn't have the effect. People are also, there's been claims that pretty soon, or image recognition technologies will be able to, do the job of a radiologist, essentially. Detect everything that needs to be detected in medical images. Does that mean that radiologists are going to go away? No, it's going to make their job a lot more interesting.
Well, let me ask about medicine. And when will, I guess the metric is, will we start to see the impact of AI on morbidity or mortality statistics? Do you expect that to be a near-term thing?
Absolutely.
So, yeah.
Both of you.
Well, I was going to make a comment. So I really believe that AI methods broadly, and I mean the constellation of AI, not just machine learning, but decision-making, planning, perception, and so on, natural language, is the sleeping giant for healthcare. I'm just amazed how little has been transferred into real-world use. And I'm talking not just about the latest and greatest deep learning and higher accuracy classifiers, but for several decades now, methods have existed that would clearly ease the pain, raise the quality of care, reduce costs, and save lives for decades. And it's hard to understand. People have theories as to why there's such resistance to this transfer of this technology. But yes, I think we do want metrics. Here's a metric for you. Latest and greatest estimates are that nearly 250,000 patients in the United States alone, and this is a worldwide problem, nearly 250,000 patients are dying annually because of avoidable human error in hospitals. Now, if we just thought about what kind of safety nets, if we understood the kind of errors and the kinds of problems with cognition and with care that are being observed in hospitals, what kind of safety nets could be created that would save 250,000 lives? Forget about a few lives, or percentages, but a large number of lives.
Yeah, and I feel like healthcare is in kind of a global state of crisis, where the availability of healthcare is scarce and the prices are very high. And a big part of that is because doctors don't have, there are not nearly enough doctors to deploy the cures and technologies that we already have effectively. And my genuine hope is that these technologies can expand the power of the individual doctor in order to be able to care really effectively for the people that they're faced with. And I agree. I think that this is a huge opportunity, but it's one that has to happen in concert with the medical community, right? I think it's laughable to imagine that an AI tech company is going to, solve healthcare, right? That just isn't what's going to happen. I think that's what's going to happen is that the technology is going to move into these spaces by working very, very closely with doctors and care providers to come up with the solutions that they need to multiply care for their patients.
Yeah. So it's obviously one of the hottest issues in society. I wanted to ask it from a slightly different perspective. We talked about augmentation and using AIs to augment certain kinds of human behavior. The way I've sort of framed it for myself, you have this choice. You can augment the doctor, and IBM has made a lot of sort of publicity around augmenting doctors with Watson. But from a societal point of view, you could also think about augmenting the physician's assistant, which might actually create less expensive and better health care for all. Who makes those decisions? And what about the issue of de-skilling? As these technologies, how do you deploy them so you don't lose human skills, or do you care?
Yeah, so I mean, I think the answer is it's not about either or. It's about looking at what the situation is on the ground, what the underserved needs are, and addressing that problem directly. So, for example, we have a project that works on trying to screen for diabetic retinopathy, which is the world's fastest growing cause of preventable blindness, and is enormously underserved in India. There are not nearly enough doctors to perform this particular screening task in order to prevent blindness. And 45% of people who eventually develop this disease lose some of their sight before they're diagnosed. That's a task that can be automated in order to refer people into care when they need it. And so by extending the ability of, as you say, the physician's assistant or the NGO worker to be able to go into underserved populations and be like, no, you really need to see someone because you're a tremendous risk, is exactly the kind of opportunity that you need to seek out, because it makes a huge difference, right? You're able to multiply the impact of that one ophthalmologist who is around.
Okay.
Now, we shouldn't just talk about clinical care, but also foundations of science. I always think that for many years now that one of the big payoffs in machine intelligence will be in scientific companions that understand data sets that help physicians and scientists reason about causality versus association, design interventions, and help triage experimentation. And there's been some really interesting work, of course, in biomedical informatics that you would actually call AI.
And does that move you? Are those systems being creative in a human sense? Is that will AIs be creative? Are they already? I mean, I've seen recent painting stuff, earlier painting stuff, but what about scientific invention?
So I have kind of an extreme position on this. I don't know if we differ.
I'm not sure.
So I think that creativity is human creativity is something that humans appreciate largely because of the social connection that happens. So we have a project called the Magenta Project that focuses on using artificial intelligence to help facilitate art generation. And we've done some interesting things around building tools for musicians to be able to create new kinds of sounds, new kinds of music, to be able to compose more effectively. But from my point of view, it's not about making entirely machine-generated art. It's about making a tool set that allows us to create new things. And I'm pretty hard line about that. That I think that the best case is that you're inventing the camera, or you're giving photographers Photoshop. You're giving them technologies
AI
that
is
allow
just
them
a
to
new
make
paintbrush.
It's just a new paintbrush.
Right. So it could,
yeah.
you know,
You
it could
disagree?
be. Well, I don't disagree, but there is. I mean, certainly AI is already being used, or at least experimented with, as a help for a creation tool, as a creation tool, as a way of you know, helping people who have creative juices but don't necessarily have the technique to sort of you know, produce a piece of a creative piece. You know, we've been working on, you know, producing paintings and graphic arts of various types. And of course, there are practical applications of this, but beyond this, I think the question is, I think I sort of agree with you that there is a social component to artistic creation. It sort of prompts the question of really what art is. So I'm a big jazz fan. I live in Greenwich Village in Manhattan, which is great because I can walk to all my favorite jazz clubs. But what really is the essence of something like jazz, which is sort of a live performance art, is the direct communication of human emotions through a medium that, you know, requires a little bit of active thinking. So you can already have machines do jazz improvisation, and it sounds technically great, but they don't communicate any human emotion. Yeah. Now, it's quite possible that very, very far in the future, we will be interested in receiving robot emotions, but that's not going to happen for a long time.
So let's make a comment just to bring back the question that framed it, which was biomedicine and science, and of jazz and guitar and so on. By the way, Greg's a guitar aficionado. And I think in science, you can look at creativity as part of expanding the generate and test process. And it might sound mechanical, but there's been some great work, for example, on discovering unknown positive effects of drugs from looking at large-scale, population-scale electronic health records. If you did that without the help of machines, you'd have all sorts of correlations and so on. And machines now are working hand in hand. This has been a project that I'm working with folks in Israel, hand in hand to help you constrain this search and test with something called propensity scores to pop out surprising effects of drugs that you didn't know. This is like sort of new purposes for drugs that were already being used for something else. And so absolutely, these tools can help with the creativity of human scientists, and it might sound mechanical, but generate, test, score can be a very helpful pen and paper or pencil and paper for a human scientist.
Yeah. Let me ask about aging in a particular way. I mean, you know, the computing industry as a whole has done very little for the aging population so far. I think none of us understand how different society is going to look just 50 years from now. It's really much more Methuselah than I can't say it, than any of us think. But I wanted to ask about, so right now, there is evidence that the less isolated people are, the longer it takes them. I mean, it offsets dementia. It offsets senility. So could you design a conversational agent? I mean, is this a positive vision, or is this horrific? I can't get my mind around whether, if someone, you know, if you can design a conversational agent that is so, you know, witty and enlightening that somebody actually enjoys talking to it, but they don't talk to other humans, is that a sign of how terrible our society is? Or if they, you know, have a better life, is it okay? Have you guys thought about this? And I mean, the conversational agents are moving quickly enough that this is going to be a real issue soon. Right?
Well, so conversational agents are actually, so the technology is not progressing as fast as everybody would like it to progress.
Yeah.
It's actually technically extremely challenging. And it relates to a point that we were making at the beginning of this, you know, about common sense and things like this. So it's currently very frustrating to talk to a chatbot because the depth of their knowledge is extremely limited, narrow. Most existing deployed chatbots are actually entirely scripted by people. There's very little machine learning going on there at the moment. All of us are furiously working to fix this, but we don't really have a solution. We have things that might, you know, help us build chatbots that are kind of somewhat specialized in areas like, I don't know, movies or restaurants or sports or something like this. And, before we have chatbots that can have general discussions that are frustrating, can answer any question whose answer is somewhere available, this is going to take quite a while.
Yeah, John, I don't believe that humans will ever lose the deep need for connection with other human beings, no matter how good our AI gets.
Yeah. Okay. Microsoft did this very interesting experiment in China with a chatbot called Xiaoice, where 25% of a very large group.
We're doing. I mean, it's not past tense.
Doing.
It's
okay.
going along.
How many?
Oh, but it's a huge phenomenon.
25% of the people who used it texted "I love you" to it. Now, some of them were probably goofing around, but some of them were probably serious. I mean, the Turing test is kind of a test of human gullibility, isn't it? At the end of the day, I mean, yes. and it turns out the bar is much lower. Well, so we're than you might think. I covered as a reporter the first Turing test in 1992 or 1993, and the interesting thing about that test, and the programs were very little better than ELIZA at that point. They had two groups of judges. One group were computer scientists, but the other group they hauled off the street. And for that group of judges, the Turing test was passed in 1992. So it's an interesting sort of sliding bar. I'm going to get to these questions. One last question, because increasingly we're surrounded by this soup of algorithms that give us all kinds of advice that we now take willingly. Everything from what kind of Korean barbecue to eat to who to marry. And I guess the question I want to ask is, how tight should the bond be? If you're a Star Trek fan, there is this notion of Borg. Resistance is futile. You will be assimilated. And I wonder about sort of where the line is as we augment ourselves. I mean, is it important that you be able to take the glasses off? What's the, how do we keep our humanity in the face of this set of technologies that are coming up?
One of the pillars of the 7 pillars you mentioned of the AI partnership is on deeper societal influences of AI on people and society more broadly. And I think we need to figure out how to stay above the fray a bit and understand the influence of technology on people and society. That's a tough challenge to understand how we're being influenced. Are we being influenced in ways that we would, if we were looking outside in, be happy with? And some of the more subtle, powerful effects are the scary ones per being in control of our destiny.
Yeah. Okay.
So one thing I get slightly annoyed by is the description of all of this as algorithms. They are not algorithms. I mean, all of the AI machine learning systems that are used, the algorithm itself basically can fit in one page of code, and it doesn't really represent the functionality that the machine does, right? All of the knowledge of the machine is in the training, and that's not the algorithm. It's a layer on top of the algorithm. So I wouldn't use that term.
Interesting.
Okay.
But it's this structure. What do you call it? It's not data. It's metadata or something. What is it?
It's knowledge. Okay. It's compiled knowledge, trained knowledge. So it's the difference between sort of brain and mind. Maybe it's kind of similar type of difference. So I think every time a technology has appeared in history, people have worried that the use of the technology would stop people from learning a skill that they considered absolutely essential to survival, right? So, I think when agriculture was invented, and then in Europe or Eurasia, people figured out how to use animals to kind of plow the fields. They say, but you're going to get weak now, because you're not pushing the thing anymore. And
it was true. That
right,
was actually true.
It's true. And then when fire appeared, I'm sure there were naysayers that said your teeth are going to decay because you don't need to chew anymore. I mean, and every time books when books were generally started to be generally available, there were people who said you shouldn't read books, and then centuries later when TV appeared, you shouldn't watch TV, or you shouldn't spend so much time on Facebook. I mean, every time a new technology pops up, you have people who say, don't do this too much because you're going to lose this old ability that we relied on. And it's just, that's the way the world evolves.
Okay. So, Jan, I'm not going to ask this question to you, but it's the first one on the list. So I will ask it to the group. Can you stop fake news with AI?
So do you want to answer? I think the answer is no. You cannot stop fake news with AI alone. But I believe that you can use AI as a tool in order to improve the quality of social discourse and civic discourse. And I think that it's a very powerful and important tool in being able to deal with political discourse and with the most rudimentary form of this, which is spam, right? So, AI is the only thing that has continued to make email usable by protecting us from, the chatter of fake email. And in our social exchange networks, we didn't realize that this was as much of a problem. And I think that we were a little bit late in deploying it as a tool. It won't cure the problem. It won't make it go away. But it's something that we can and should apply in order to greatly improve the situation.
And let me just say
what he said.
Well, I'll just quickly say that I think that one of my biggest concerns about the abuse of AI is AI being used and data and reasoning and decision-making and planning to manipulate human minds. And I think we've barely seen that surface scratched by adversaries and a number of different groups that have all sorts of interesting ideas about how you can take what was called marketing in one generation and propaganda in another to personalized algorithmic manipulation of minds.
And do you see the possibility of inventing effective countermeasures?
I do think that machine intelligence will be on the path to solutions there, as well as policy issues, laws. I think that this is a very, very important issue.
Okay. What AI-related ethical issues should be discussed for the next 5 years? So what kind of ethical issues are you guys confronting right now?
Fairness, bias, or removal thereof. There is good reasons to believe that certain decisions about people made by machines might be actually less subject to bias than human decisions. So that has prompted people like Jason Furman, who is the former chair of the Council of Economic Advisors in the Obama administration, to say, people are incredibly biased. I mean, there's a lot of studies that show this. This decision made by judges, and if the favorite football team of the judge has lost the night before, the decisions are harsher, or if it's just before lunch. So humans are incredibly biased, and so he says, we need more AI to have less bias. Now, the problem with this, of course, is that it's not like we have completely figured out all the techniques that are required to remove bias from AI decision-making systems. And this is one of the things that we are actually very interested in discussing in the context of the Partnership on AI, because sharing those techniques, sort of producing guidelines for how you produce a machine learning system that has as little bias as possible. So that's one thing. Then there is testing for reliability. So there is a lot of procedures to build computer systems and to test them to kind of prove that they're correct and things like this. But when those systems are trained, how do you test them for reliability? It's a completely different thing, and it's going to take a while before we really figure out how to build completely reliable self-driving cars, for example, that have been trained with data. So there's questions like this, I think, that need to be discussed.
Other directions in this great summary, Jan, include how machines that are doing reasoning or taking actions can work better with people. How do they communicate their uncertainty and competence? What best practices do we believe are these systems, especially in high-stakes areas like surgery, transportation, and so on, should they abide by when it comes to sharing confidences And what kind of machinery do we need to do that well? For example, systems that will pass the control to a human being when they're less confident versus being overconfident. That's a really interesting issue that we might need best practices on how to do that well and what kind of signaling standards we need when it comes to people working with machines. There are several other very, very important directions. A question coming up in certain quarters now is, where is AI appropriate? When should automation be tried out, given the current status, the current reliability of a technology, given the sensitivity of the context and the domain, criminal justice, for example, and the trustworthiness of the user? Should technologies with this kind of power be given or be developed for oppressive regimes, for example?
Next question. We have been discussing the, quote, social, unquote, good achievable with AI, but this social good is for our elite society, for those of us who are sitting here tonight. How will AI benefit the billions living in poverty and in war? How about in poverty? How does it affect the non-first and second world?
We're starting to see quite a bit of work on like how can you do, could AI be used to help sustainable farming, for example? And this is not something that's already kind of widely deployed or practical, but there's certainly a lot of applications of AI systems in kind of small corners of the economy, and it might take 20 years to disseminate, as we mentioned earlier, for that sort of will enable people in regions of the world that are where the infrastructure is not what it is here, to profit from those things. So I mean, it's quite a lot of work also on providing things like internet services to corners of the world that currently do not have infrastructure. That's a big divide. I mean, you can't have you can't use AI systems unless you have at least some way of accessing data. And it's not like people can't buy smartphones. It's more like there is no service for the smartphone to talk to.
Yeah. And I think that this is, I think that it's a moment of opportunity, right? Like imagine that you could go back in time and you knew that you were standing at the very beginning of the revolution in textile manufacturing, or you knew that you were standing at the very beginning of the mobile phone revolution, right? What would you do differently in order to have those technologies have the kind of equitable, progressive impact on the global economy that we hope for? I actually believe that we're at that kind of moment, and that's why this discussion is relevant to have now. And I think that there's a huge reservoir of technical folks, of engineers and scientists who want to help to affect that change. But it's not, I think if you just let engineers be engineers, the solutions may not come, right? I think that this is really something for sociologists, for policymakers to get in front of this. This is an opportunity, and I think that if we don't do anything, it'll kind of all be fine. But I think that we will miss this opportunity to distribute it more equitably.
We could have spent this whole session on AI for the developing world, and we would have run out of time. It's such a fascinating and promising constellation of opportunities. I just read this morning about a Microsoft project called FarmBeats that discovered it's about AI for agriculture, communications for agriculture in developing countries, as well as developed countries. But they just discovered that with an application that did forecasting with multiple sources of data that would recommend to farmers, and this was in India, when to sow their crops, when to plant their seed. They got a 20% boost in yield.
How does it reach the farmer? Through what kind of a device does the farmer have to take advantage?
Well, to date, it's farmers getting involved in special programs who download software and a sensor array and so on and get on the net to appreciate this. But the idea is to figure out how it can work for small groups and then roll it out to larger groups. But think about education, doing automated education in a compelling way. that understands bottlenecks in conceptual understanding, and that can help people without as much human intervention. There's been some great work in predicting epidemics like cholera in advance of them happening, so you can triage short-acting vaccines and getting hydration to locations in advance. There's a whole area that's evolving, and I've seen one phrase you called AI for the developing world. There's actually a website, ai-d.org, and so there's definitely a promising space.
Okay, that's good.
So as technologists here on this stage, we sort of like to talk about like the promises of AI, right? All the positive sides and everything. But there are risks. So I can tell you what I'm worried about AI. This is not a Terminator scenario or anything like this. It's more kind of projecting ourselves back in the late 19th century, in the Industrial Revolution. The Industrial Revolution certainly had a global sort of increase, produced a global increase of wealth, but it wasn't very well distributed. That's what led to the Gilded Age. And to some extent, we are in a new Gilded Age. The result of the first Gilded Age was the emergence of Marxism, essentially, which eventually split the world for 75 years, created sort of a disconnection between two halves in the world, and sort of a bunch of wars across the world. So the modern Gilded Age and evolution of technology, of which AI is part of, but certainly not the only factor, might lead to Marxism 2.0, unless policies are enacted to prevent this from happening. And this tends to happen faster than you can foresee. And so that's really the scenario I'm worried about. Increased inequality with no kind of policy that comes soon enough to correct it.
Yeah. You've sort of answered the next question, but I want to ask it again because multiple people asked it, and maybe give others a chance. Since AI will be introduced to the public for social good, wouldn't it also carry risks such as viruses? If so, is there any safety measures being developed to protect public safety? It's a slightly different question, but you guys talk about safety and
I mean,
Google has been actually, you have a technical paper.
Yeah. So I think that there's a bunch of new technical work on AI and safety, and I think that really, when you say AI safety, initially people are like, safety sounds scary, right? But actually, I think that safety in machine learning and AI systems is as appropriately as boring as safety in car manufacturing, right? That it's about anti-lock brakes, and it's about airbags, and it's about crash testing, and it's about making sure that systems are working as intended. And this is something that the community really has to take seriously, right? Understanding, as Jan mentioned, how we test software systems for vulnerabilities when they contain a machine learning component is something that's very actively being studied. There are a lot of engineers working to solve these problems because we don't want our products to break. We don't want our products to get hacked. And so the incentives are aligned, I think, to do all of these things in the right way. And I'm very happy that it's becoming a topic of just open conversation, an engineering discussion about how do we implement the kind of safeguards that we need, so that it's a matter of, if we've decided this is how we want the system work, then we can guarantee reliably that this is how it works.
Yeah, there's a very interesting challenge for AI, which is even bigger in AI than other areas, which is the open world problem, where the open world is so much bigger than the laboratory, and the test set is so much broader than the test that you use to train and test your algorithms. And it's led to a kind of the growth, early days though, of a science of automation in the open world, which includes ideas about an actual science of unknown unknowns and how you test for them and how you use human beings appropriately and triage their attention so they can probe systems. Looking back at the literature on fail-safe technologies like air brakes, what was the intention there? How did they work? Can we do those kinds of processes and techniques and mechanisms for AI systems? This whole area of inadvertent defects is a very interesting area to look at for AI systems, in that they tend to, in the open world, touch so many parts of the world that weren't part of, the laboratory, the test tube version of the systems.
So I think we're being told to wrap up, but let's end on a tough question for this panel.
As opposed to the other ones, right?
The softballs.
Yeah.
Whose personality will a fully realized AI have? I'm looking at a row of white men, that would be us. Are there conscious or unconscious biases that AIs will have? What efforts are being made around diversity?
Yeah, so this is incredibly important, right? And I think that the availability and the dissemination of these technologies, the raw material to build these technologies globally is essential, right? I think the only way that we get the removal of the bias from these systems is to have it be both that there's a science around understanding the bias, but that the practitioners of these technologies are not, English-speaking people that happen to be in North America, right? Like, I really think that it's very important that the underlying technology is democratized and that the education about how these things work is democratized as much as possible. And that's not just talk. I mean, we open source the underlying software that we use to build machine learning systems at Google because we want people all over the world from every background to be able to learn these things to build the thing that they imagine, because it shouldn't be left to one group, any group.
This has been produced in association with Partnership on AI and the Computer History Museum. I'd like you to join me in thanking our panelists. It's impressive what this industry is doing.